We are instructed here to write an inequality that is represented in each particular graph. In the first graph, you're noticing that we have an interval between two different numbers. So really, we are needing to be greater than 3, but then at the same time, so the word and we also need to be less than or equal to, because it's got the closed dot, 6. So we've got like an and sort of statement. So the more common way we would write this is if we call these numbers that are represented in the graph x, then x needs to be equal to or less than 6, but at the same time we need the number 3 to be smaller than x. So that would be the most common way to write that. So this is an and inequality when we see this type of a graph. Another way we could write this is we could say that x has to be above the 3 and at the same time x has to be equal to and below the 6. So either way you want to write it, whether you write it this first way or the second way, they are both equivalent ways to write that and compound inequality. And then with this graph right here, it's just one direction in that you're starting basically at 5, or I guess just right below 5, and then you're growing forever towards infinity because it's got the arrow. This is a simple inequality because really you can just say that if we call these numbers here, let's say like n, then these are all numbers n that are less than strictly below the 5. And then, yeah, so that's a simple inequality. It doesn't have any ands or ors or conjunctions, right? It's just like one comparison, one less than between two different quantities there. And then this one right here, this is a compound inequality because you do have multiple comparisons going on at the same time, but you don't need things happening at the same time as each other because you got separate conditions, so you can just join these conditions together with the word or, and you need to use the word or. So this first condition over here, if we call these numbers, I don't know, like z, then the number z could be equal to or less than -5, and then write the word or, and then or the number z could be just strictly above 5 because you got the open circle right there. So that would give you that compound inequality there that's in or. Cool. Okay, so just writing some more inequalities but kind of using some words. So it says to write each sentence as an inequality and then graph the inequality. So this first statement says here that the temperature T is at most 12 degrees Fahrenheit and no less than -20. So if the temperature T is at most 12, right, the most it can be is 12, what that really means is that T could be at 12, but has to be below. Now, if it's at most, it can be equal to 12, so we can include that. And then no less than means it can't be less than, right? So it could be equal, because that's not less, but it also could be more, because that's not less. So then we need -20, you know, it could be equal, but then the temperature has to be more, right, not less than. So ultimately we get that going on, right? If it's at most 12 and not less than -20, it's got to be somewhere between. And so when we see this visually like this, it'll look like this, and we're going to have filled in circles like that. So that writes the inequality, and then hopefully the picture helps you kind of make sense between the sentence and all of that sort of stuff there. Okay, this is saying that we need a number c to be at least 5 1/3 or is less than -1. So now if we've got this word or, we don't need necessarily both of these conditions to happen at the same time for this overall statement to be true. So if the number c is at least 5 1/3, then at the least it's 5 1/3, which means that it's going to be greater than. Now it can be equal to be at least 5 1/3. And then, or it's less than -1, so c is less than -1, it's just strictly less than. So that writes that out. If you were to graph this, you'd have your 5 1/3 there, and it could be equal to and above, and then your -1 is a smaller number, not equal to and below, and that gives us kind of the graph of what's stated right there. This says the pH level of a popular shampoo is between 6 and 6.5 inclusive. So you all know what between means. Between means to be in the middle of, right? So if this is 6.0 for the pH and this is 6.5, then of course you want this. Now, either you might see this word sometimes when you're dealing with betweens. Sometimes you might also see the word exclusive. So inclusive means to include both of the endpoints. Exclusive means to exclude. So because it says inclusive, you want to include 6 and you want to include 6.5. So I should have a filled in circle and I should have a filled in circle because we want to include those as possible pH values. So as an inequality, we could say that the pH is strictly between the 6.5 and the 6.0 because of that inclusive. So if it did say instead exclusive, you're going to exclude the endpoints. So that would mean that your pH would be between 6.5 and 6.0, but then you'll notice that you'll just have strict less thans, which then of course in the graph would mean you'd have empty circles instead of filled in circles. And then the last one says exclusive, right? So between 9 and 100 exclusive. So if this is 9 and this is 100, then you're not going to include those, but you're going to go between. And then that just means that 9 would be between 2-digit integers. So I don't know, pick a, how about Z to represent the integers, and then between 100, and then that's going to represent that. Excellent. All right, and then one last kind of little example here. So your science exam scores are 81, 88, 93, and 91. What are the possible scores you can earn on the next test and still achieve a B average on the exams? So, well, what does a B average mean, right? So we should come up with some way to define that. So let's say that a B average is that you're in the 80s, right? 80%. So like more concretely, like if you get an 80, you're good. But then I guess you want to, if you get a 90, like you're in the A range, right? So we can say just strictly less than 90, like that's going to be a B average on the exams, right? So you need to get between 80 and 90, right? Like that's what you want your average score to be. So you already have taken 4 tests, right? But you're going to take a next test, so you're going to take a 5th test, and you want your average to be somewhere between 80 and 90. So think about how are you going to get your average? Well, your average is going to be taking all of your scores, 81 plus 88 plus 93 plus 91, dividing by your test. But you have to take a 5th test yet. But we don't know what your score is on that 5th test. So let's represent it, right? So let's represent it with some sort of variable. So let's say like t for your test score on your next test. So if we introduce a variable, we should probably define it. Say t is the score on your 5th test. Now, if we're going to get your average score, we're going to have to divide that all by the number of tests, which is 5, right? So there's your average score. Now that average score needs to land somewhere between 80 and 90, so I need it so that 80 is going to be less than or equal to that, but then this needs to strictly stay below 90, right? So now we've kind of set up a mathematical model that represents what's going on, and then we can actually kind of use that to solve for the possible values that t can be, right? So if we add together, I guess, all of these 4 digits right here, you're going to get... oh boy, let's see here. 180 and then 160 is going to give us 340, but then we're going to get, I think, 353 if I didn't make a mistake there, plus t over 5. And then that's going to be less than or equal to 80 is less than 90. Okay, so if we want to solve for t, you're going to have to times this by 5 first, which means you times everything else by 5. It's a positive, so you don't have to change the inequality symbol. So you're going to get 400 is less than or equal to 353 plus t is less than 450 when you times by 90. Yeah. And then you can go ahead and subtract the 353, so you get the t alone, and then do the same thing to all 3 parts right here. And then that means that you're going to then get 47 is less than or equal to t, and 97. Yeah. So that tells you the possibility. Oh, but the inequality symbol, I got to change that. That has to be a less than. So in order to get a B average, you've got to score basically like a 47 and then like a 96.99, right? Like if you get a 97, then I guess you'll end with a A in the class overall. So to maintain a B average, those would be the test scores you'd have to score on the 5th and final test, I guess.